Hi guys, following on from our work on parametric equations, I'm going to really go into a bit more depth on one of the most common uses, which is in projectiles. Now, I often use this as an explanation for the use of a parametric equation. One of the key things I said was that say you've got an object at the top of this hill here, let's call that a hill, and if you push it off in that direction or you send it out there, by the time it's left you and the force has stopped being applied, there's only one force, and that is its weight, and that is all that's acting on it. Now, what we know about that is it's constant, and it gives a constant acceleration. And what that does mean is that we can pick and use our constant acceleration formulae. And our constant acceleration formulae, the proper name for them is that, we've got the kinematic equations, but you know them as the Suvat equations. So we're going to think about the Suvat equations, and we're going to split some of these into different components, things that are vector forms. So we would have an Sx and an Sy and a Ux and a Uy, etc. So when I look at this question here, it says a particle is projected horizontally at 25 meters per second from a point 7.8 meters above a horizontal surface. So already you know what I'm thinking is, okay, let's get that information on a diagram. So I know that it's setting off there at 25 meters per second, and it's at a point 78.4 meters up. Okay, so we now need to think, how does this travel? Now, the main equation that we use is S equals ut plus half at squared. And if we look back here, I've got ax and ay. For this situation, or for any situation, that is always equal to 0. So if I'm thinking, okay, so here, if I looked at horizontally, Sx is equal to Ux t plus half ax t squared, I can see that what I've got going on is Sx, that's the distance travelled horizontally, is equal to Ux. Well, our initial velocity in the horizontal direction is 25, so that'd be 25t, and I know that acceleration horizontally is always 0, so I've got half times 0 times t squared. Well, that just all goes to 0. So I know that's my situation, and if I were to look at it vertically, Sy is equal to Uy plus half Ay t squared. So I know that Uyt, Sy equals, well, it said this has been projected horizontally, so it's got no initial velocity in the y direction, so that's 0. And I know that Ay is nearly always, or is always, minus 9.8. So I've got a half times minus 9.8 times t squared So that's minus 4.9 t squared. So that's how far it will travel vertically, and this is how far it will travel horizontally according to time t. Right, so now when we look back to the actual specifics of this question, it says find the time taken for the particle to reach the surface. So I want Sy, and I want it to travel down this distance. So I'm going to put that equal to minus 78.4 is equal to minus 4.9 t squared. Well, if I divide both sides by 4.9, I think I'm going to get something fairly reasonable. So minus 78.4 divided by minus 4.9 is equal to 16. So t is equal to plus or minus 4, but we can't have negative time. So t is equal to 4 seconds. So that's the time taken for it to reach the surface. So the key thing there was to recognise that it travelled down 78.4 metres. Remembering the acceleration was going down as well. So it's important to keep those two the same sign. You could have thought of them both positive, but I like to think of the positive direction as being upwards and in that direction as well. Right, B, the horizontal distance travelled in that time. So I've got Sx is equal to 25t. So that would equal 100 metres, because I would have to do 25 times 4. Okay, so really for horizontal projection, you've got these two formulae. So Sx is equal to ut or uxt. That's always going to be the same because there's no acceleration, so that disappears. And Sy is always going to be equal to minus 4.9 t squared because there's no initial vertical velocity. So from then on, we're just using those two equations. Basically S equals ut plus half a t squared, but eliminating some of the bits and then working parametrically as we have been doing. So it's pretty straightforward.